Lesson 3.6, Quadratic Inequalities. All right, the first type of inequality we're doing is one with two variables. This is x and y, and we can only solve those by graphing. So to graph a quadratic inequality in two variables, first of all, we're going to graph the function if it was an equals. And then we have to decide if it's a dashed line or a solid line. If it's less than or greater than, it's a dashed line. But if it's equal to, less than or equal to, or greater than or equal to, it's a solid line. And then you have to shade. To shade, pick a point not on the line and plug that into your inequality. If it's a solution, you shade that side of the line. If it's not a solution, shade the other side. Or solve your inequality for y. If it's y is greater than, shade above your line. If it's y is less than, shade below the line. So let's try this example. Let's graph y is greater than x squared minus 10x plus 25. So we need to first of all graph this. It does help if we know the vertex, so maybe we'll actually find the vertex here. X equals negative b over 2a, so it'd be negative a negative 10 over 2 times 1, which is 5. So when I make my table, I'm going to center 5 in the middle there, and put it in the calculator. X squared minus 10x plus 25. So I have 2, 9, 3, 4, 4, 1, 5, 0, 6, 1, 7, 4, 8, 9. All right, so graph those. 2, 9, 3, 4, 4, 1, 5, 0, 6, 1, 7, 4, 8, 9. All right, so those are all the points. Now we have to decide whether it's a solid or dotted. Since it has equal to, it is a solid line. So we can put that in. And then we have to shade. Since it's y is greater than, we shade above. All right, let's graph the system of inequalities. So let's take the first one, find its vertex. So b is 0. There is no b, so it's 0 over 2, which is 0. So when I make the table for it, 0 is going to be in the middle. So then I'll make a table in my calculator. So I have negative 3, 5, negative 2, 0, negative 1, negative 3, 0, negative 4. So there's my table for that one. I graph that. Negative 3, 5. Negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, 0, and 3, 5. It's not equal to, so it's dotted. So it's a dotted line because it's not equal to. And then we have to think about the shading. it's y is greater than, so we shade above. Now let's take the second one. X equals negative b over 2a to find the vertex, to find out where our table has to be centered. So that'd be negative 3 over 2 times negative 1, which gives us 3 over 2, which is 1.5. So on my table, 1.5 is kind of going to be the middle. So I'm going to put this in the calculator. And get a table. So if negative 2, negative 6, negative 1, 0, 0, 4, 1, 6, 2, 6, 3, 4, 4, 0, and 5, negative 6. Graph those. Negative 2, negative 6, negative 1, 0, 0, 4, 1, 6, 2, 6, 3, 4, 4, 0, 5, negative 6. It's equal to, so it is a solid line, so I can put it in as a solid line. Like that. Try to make it nice and thick. Alright, and then its y is less than, so we shade below. Alright, the answer is the place where they're both shaded, so we're going to make that nice and dark so that we can see exactly where it is. These are both places where they're both shaded. You get this nice little oval type shape. The other type of inequality are when there's only one variable, such as this one here. P squared minus 4p is less than or equal to 5. What we're going to do is we're going to make it equal to 0, or in this case, or greater than or 0, less than 0, but 0 is going to be on one side. So to do that, we'll subtract 5. Subtracted 5 from both sides. And then we're going to factor or use the quadratic formula to find the zeros. So let's try factoring. So what times what makes p squared? It's p times p. What times what makes the negative 5? Might be a negative 5 and a positive 1. And we check. The outers is 1p. Inners are negative 5p, which makes negative 4p, and that is the middle, so we did it correctly. Erase that. And then you take each of those factors equal to 0, and you find that p is 5 and p is negative 1. Next, we're going to graph these zeros on a number line. Unfortunately, that lined up on top of my number line, but anyway, we're going to graph these on a number line. We had 5 right there. and we had -1 right there. Now we have to decide, I filled in the circles, but you should probably decide, are they filled in circles or not filled in circles? Since it's equal to, we'll say it's filled in circles. If it's not equal to, then they'd be open circles like that. Notice it divides the number line into 3 parts. We have the first part, second part, third part. We're going to pick a number in each of these 3 parts to test. So in this first one, maybe let's test -2. The middle, I like testing 0. We're going to test 0. And in the upper part, let's test 6. All right, so let's try the -2. I'm going to plug it into the original inequality. So it'll be -2 squared minus 4 times -2. So that's 4 plus 8 is 12. That is not true. 12 is not less than or equal to 5. Let's try the 0. 0 squared minus 4 times 0, less than or equal to 5, which gives us 0 is less than or equal to 5. That is true. We like that part, so we're going to draw a line over that part. And then we're going to try 6. So it'll be 6 squared minus 4 times 6. Again, this is in the original inequality. So it'll be 36 minus 24, or 12. And 12 is not less than 5, so that is false. So we already did this. We plugged our points into the original inequality to see if it's true or false, and now we write inequalities for the regions that were true. So it's true in this middle region, so our answer is -1 is less than or equal to p less than or equal to 5. If the other regions were true, you might have had p is less than or equal to -1, p is greater than or equal to 6. But in this case, the middle one was true. If you want a shortcut, we could do a shortcut. We could solve the quadratic inequality in one variable by graphing the quadratic. So you make it equal to 0, you graph it. When the graph is below the x-axis, that's when it's less than or equal to 0. When it's above the x-axis, that's when it's greater than or equal to 0. So, if we went back to our previous problem, this is the equation here, the inequality, that was compared to 0. Notice p is positive. It's a positive a, so that means it's opening up. So the parabola, if I graphed it, would open up like that. And we want it to be less than 0. So if it's less than 0, that's where it's below the axis. Notice it's below the axis between the -1 and the 5. So if here we wanted the greater than 0, it would be up here at the end, so you would say x is less than -3 or x is greater than 1. If you wanted less than 0, that would be in the middle, and you would say -3 less than or equal to x less than or equal to 1. So if it's above the number line, it's greater than 0. Where it's below the number line, it is less than 0.